together because they're in slope-intercept form. So go to your y equals menu on your calculator. If there's something in there, clear it out. If one of these plots is dark, you need to make it not dark. So let me show you the difference. So if one of your plots looks like that, you don't want scatter plot on, so you just arrow up, hit enter, and turn it off. So none of the plots should be turned on. So you should have clear y equals menus to type in your two equations, y equals x plus 3, x plus 3. And the other equation is y equals 2x minus 1. Make sure you use the big subtraction key and not the negative key. See here, subtraction key, do not use negative key under the 3 because it'll mess you up. And then because I don't know who's been using this calculator, I always just hit zoom 6 because that resets to standard viewing window. So you literally just type the number 6. You don't have to arrow down. And then it should give you your two lines. And hopefully we can see that they intersect, and we do. So we don't want to eyeball it. We want the calculator to tell us what is that exact intersection point. We could look at the table and hope that it's an integer where it intersects. But if you go to second calculate, which is above the trace key right here, so second calculate, one of the options is to find an intersection point. So you just select choice 5. Are you with me so far? And it's going to ask you 3 questions down here. It says, is my cursor on the first curve or the first graph? And you can just hit enter for yes. And then it's asking you, is this red line your second curve? And you hit enter again for yes. And then it asks you to put your cursor near the intersection point. So I'm just going to arrow up my cursor because sometimes it could intersect at more than one point if it's like a parabola. So is that your best guess? Yes. So you just hit enter a third time and it tells you that that exact intersection point is at 4,7. Did everyone get it to work? So it found it for you on the calculator? So you could double check your graphing this way. All right, so I'm going to write my solution was 4,7 on my paper. Does anyone need help with that step? And the steps are there for you if you forget. All right, and I wanted to show you another example because this one does not fit on the graph. So I just want to show you how you can zoom out if you can't see it. So this first equation I could type in, but this second equation I have to put in slope-intercept form first. So even to use the calculator, you have to be smarter than the calculator. You have to be able to put this in slope-intercept form, or else the calculator can't do its job. So there is a reason why, even if you have a calculator, you need to know slope-intercept form. So I'm going to subtract 2x to the other side. So I'd have 3y equals negative 2x minus 27. And then what's my last step to get y by itself? Divide by 3, divide by 3, divide by 3. So y equals negative 2/3 x minus 9 is my second equation. So now I have 2 equations to put in the calculator. So see if you can put those in and graph it. And then when you cannot see your graph, we're going to need to zoom out. 2, you're going to hit the negative key. Yeah. So negative 2 divided by 3x. Negative 2 divided by sign. Right. So you need the negative key here, but the subtraction key here. So the little guy goes in front of the number when it's a negative coefficient. That's the one that's down here with the numbers. But then when it's an operation like subtraction, you want to use the subtraction button. And the other one is x minus 29. So that's the bigger subtraction operation. And then we've already hit zoom 6, so we don't have to hit zoom 6 again. We could just hit graph. And hopefully you'll get something to show up. I can't remember what shows up. I can see one line, but I can't see the other line, it looks like. It's off of my viewing window. So you can hit zoom 3. So if you hit zoom 3, it's not going to do anything. You need to hit enter to tell it to zoom out. So now I can see both lines and the intersection point. So now follow the steps to find the intersection point. Second, calculate intersect. Curve 1, curve 2, best guess. And then I think you should be able to go through kind of the rest of the problems as you go down the paper yourself. To zoom out, zoom 3, enter. If you enter twice, it'll actually zoom you out twice. If you hit enter once, it'll only zoom you out once. So remember, you do first curve, second curve, intersection point. It ends up being at an integer, right? So if I'm going to do the third one, it's 1/2 x plus 3, negative 2x plus 8. So if I go back to zoom 6, I can see the intersection point, but they're really looking rather obtuse and acute to each other. If you hit zoom 5, it just squares up your viewing window so that it actually would look like a perpendicular set of lines. See how now I can fit the corner of my paper in there and it's a perfect 90-degree angle? So just kind of, it applies to what we just learned, but now you still have to find their intersection point. So it's nice to know that they're perpendicular, but you also have to find their intersection point. And then I wrote down that the relationship was that they were perpendicular lines, right? Positive 1/2, negative 2/1 is perpendicular, right? I don't even have to put those in because they were parallel, right? I already knew they were parallel because when I divided by 2, I got y equals 2x minus 3, and I already had 2x plus 1. What was different about the system in number 5? It had what? Oh, okay. So when you put this one, subtracting 4x to the other side, 8y equals negative 4x plus 16 divided by 8, they come out as the exact same line. Y equals negative 1/2 x plus 2 is the same line, right? Do I even have to graph that one then? Do I know what the solution is going to be without graphing it? If it's a quiz, you're going to still graph it. But for the interest of time, I want to show you those system of 3 equations. So it's going to be infinitely many solutions, right? It's going to be the same line graphed on top of itself because you're literally going to enter the same equation in your calculator twice. Did you get that without doing it on the calculator? Did you know the answer before graphing it? All right, and then it says you can solve a system of 3 equations graphically as well. So I've got, this is my equation 1, this is my equation 2. I have to rewrite equation 3 as y equals 1/2 x minus 3/2, right? Because I have to divide everything in that equation by 2. So see if you can do it. Can you type those 3 equations in? You still have 5 minutes. You got plenty of time. See if you can type 3 different equations in your y equals menu and figure out where all 3 equations intersect each other. They should intersect at one place, I hope. And your calculator cannot ask about 3 different lines. So you're just going to have to use 2 of the lines and find the intersection point, but we can visually see that they're all intersecting at the same place, right? So second, calculate intersect. I'll pick the blue and the red line, and then I'll just zoom up to the intersection point. So it looks like they intersect at -1, -2. Did you get that okay? Some of you got all the way through the end, so I appreciate your perseverance today.